65 volts present at a light fixture connected to three-way switches when the switches are off can be attributed to several possible causes. Firstly, consider capacitive coupling. Electrical wires act as capacitors, storing a small amount of charge. When wires are close together, this charge can leak from one wire to another, even when the circuit is off. This is known as capacitive coupling. Secondly, explore the possibility of ghost voltage. Electrical devices, even when turned off, can create a small amount of voltage known as ghost voltage. This is due to residual energy stored in the device's components. Thirdly, examine for loose or worn wiring. Improper connections or loose wires can create a resistive pathway through which electricity can flow, even when the circuit is intended to be off. Fourthly, consider a defective switch. A faulty switch may not fully open the circuit, allowing a small amount of voltage to pass through. Fifthly, investigate inductive kickback. When an inductive load, such as the ceiling fan, is turned off, it can generate a voltage spike that can travel through the wiring. It is important to understand whether voltage leakage is normal. Some voltage leakage is normal in electrical systems. However, excessive leakage can indicate a problem. Typical voltage leakage levels can be categorized as follows. Nominal leakage is generally less than 10 volts. Moderate leakage falls in the range of 10 to 50 volts. Excessive leakage is typically over 50 volts. To troubleshoot the issue, consider the following steps. Firstly, turn off all switches. Ensure that all switches connected to the light fixture are in the off position. Secondly, disconnect the fixture. Remove the light fixture from the mounting box and check the voltage again. Thirdly, check wire connections. Inspect all wire connections for tightness and proper insulation. Fourthly, test the switches. Use a multimeter to check if any of the switches are faulty. If you cannot determine the cause yourself, it is advisable to contact a qualified electrician for further investigation. Capacitive coupling occurs because electrical wires that run close to each other act like capacitors. Capacitors store electrical energy. When one wire carries voltage, it can induce a voltage in a nearby wire, even if that nearby wire is supposed to be off. This induced voltage is often referred to as ghost voltage or phantom voltage. This is more common in your homes where wires are run close together. Ghost voltage is often a small voltage reading that appears even when a circuit is off. It is caused by the small amount of residual energy in electrical components. Many modern electronic devices contain capacitors and other components that can store a small amount of charge even when the device is turned off. This residual charge can create a small voltage on the circuit. Loose wiring or corroded connections can create a path for current to flow even when the switch is off. This can result in a voltage reading at the light fixture. Defective switches can sometimes fail to completely disconnect the circuit when they are turned off. This can allow a small amount of current to flow through the switch to the light fixture, resulting in a voltage reading. Inductive kickback is a phenomenon that occurs when an inductive load, such as a motor or transformer, is suddenly turned off. The collapsing magnetic field generates a voltage spike that can travel through the wiring. This voltage spike can be measured at the light fixture. To accurately diagnose the cause of the 65 volts reading, several troubleshooting steps should be followed. Ensure all switches connected to the light fixture are in the off position. This will help isolate the problem. Remove the light fixture from the mounting box and carefully disconnect the wires. Use a multimeter to measure the voltage between the wires. This will help determine if the voltage is coming from the wiring or the fixture itself. Thoroughly inspect all wire connections in the circuit for tightness and proper insulation. Loose or corroded connections can create a path for current to flow even when the switch is off. Use a multimeter to test each switch in the circuit to ensure they are functioning properly. A faulty switch may not completely disconnect the circuit when it is turned off. Voltage leakage is a common phenomenon in electrical systems. It is the presence of a small amount of voltage on a circuit even when it is supposed to be off. Voltage leakage can be caused by a variety of factors, including capacitive coupling, ghost voltage, loose wiring, and defective switches. In general, voltage leakage is not considered a safety hazard as long as it is within acceptable limits. However, excessive voltage leakage can indicate a problem and should be investigated. Nominal leakage is generally less than 10 volts. Moderate leakage falls in the range of 10 to 50 volts. Excessive leakage is typically over 50 volts. If the voltage reading is above 50 volts, it is recommended to consult a qualified electrician to investigate the problem. When troubleshooting electrical issues, it is essential to prioritize safety. Always disconnect the power to the circuit before working on any electrical components. Wear appropriate safety gear such as insulated gloves and safety glasses. If you are not comfortable working with electricity, it is best to consult a qualified electrician. A multimeter is an essential tool for troubleshooting electrical problems. It can be used to measure voltage, current, and resistance. When measuring voltage, set the multimeter to the AC voltage setting. Connect the black lead to the neutral wire and the red lead to the wire being tested. The multimeter will display the voltage reading. When measuring current, set the multimeter to the AC current setting. Disconnect the wire being tested and connect the multimeter in series with the circuit. The multimeter will display the current reading. When measuring resistance, set the multimeter to the ohm setting. Disconnect the power to the circuit and connect the multimeter leads to the component being tested. The multimeter will display the resistance reading. Electrical codes and regulations vary depending on the location. It is important to be familiar with the electrical codes and regulations in your area. The National Electrical Code, or NEC, is a widely adopted set of standards for electrical wiring and equipment in the United States. The NEC provides guidelines for safe and reliable electrical installations. Electrical work should always be performed by a qualified electrician who is familiar with the NEC and local electrical codes. When working with electrical wiring, it is important to use the proper wire size for the circuit. The wire size is determined by the amount of current that the circuit will carry. The NEC provides tables that specify the appropriate wire size for different current ratings. Using the wrong wire size can result in overheating and fire. Electrical connections should be made using approved connectors. Wire connectors are designed to provide a secure and reliable connection between wires. Avoid using tape or other makeshift methods to connect wires. Electrical boxes are used to protect electrical connections and prevent them from becoming damaged. Electrical boxes should be properly installed and grounded. Grounding is an important safety measure that helps to protect against electrical shock. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse. All electrical equipment should be properly grounded. Arc fault circuit interrupters, or RFCs, are designed to protect against electrical fires caused by arc faults. Arc faults are dangerous electrical conditions that can occur when insulation on wires becomes damaged. RFCs can detect arc faults and quickly shut off the power to the circuit, preventing a fire. Ground fault circuit interrupters, or GFCIs, are designed to protect against electrical shock. GFCIs can detect ground faults, which occur when current leaks to ground. GFCIs can quickly shut off the power to the circuit, preventing an electrical shock. GFCIs are required in areas where there is a risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. Surge protectors are designed to protect electronic equipment from voltage spikes. Voltage spikes can damage or destroy electronic equipment. Surge protectors can absorb voltage spikes and prevent them from reaching the equipment. Consider using surge protectors for sensitive electronic equipment such as computers, televisions, and stereos. Electrical safety is paramount when working with electricity. Always take precautions to protect yourself from electrical shock and fire. If you are not comfortable working with electricity, it is best to consult a qualified electrician. When troubleshooting electrical problems, it is important to have a systematic approach. Start by gathering information about the problem. What is happening? When did it start? What have you tried already? Then, use a process of elimination to identify the cause of the problem. Start with the simplest possible causes and work your way up to the more complex causes. Use a multimeter to test components and wiring. Consult with a qualified electrician if you are unable to resolve the problem yourself. Electrical systems can be complex and dangerous. It is important to have a good understanding of electrical principles before attempting to troubleshoot or repair electrical problems. If you are not sure what you are doing, it is best to consult a qualified electrician. The information provided in this narration is for general informational purposes only and does not constitute professional advice. Always consult with a qualified electrician for any electrical work or troubleshooting.